All right, so you sent us on this deep dive into something called system cognition. And I got to say, the name sounds a little, well, it sounds a bit like something straight out of a sci-fi movie.
It does have a certain ring to it, doesn't it?
It does, but the more I dug in, the more fascinated I became.
Yeah.
We're talking about systems that can like actually think, adapt, make decisions, the whole nine yards.
Yeah, and what's captivating is that this isn't some like distant future scenario. System cognition is unfolding right now all around us.
Okay, so no killer robots yet. But seriously, where do we even begin to unpack this? One of the sources you sent over, a really cool YouTube video, actually used this analogy of building intelligent, like assembling a team, and it kind of blew my mind.
It is a powerful analogy. Just like a well-coordinated team needs different players with specialized skills, system cognition relies on distinct components working together seamlessly.
All right, so let's break down this system cognition dream team. What kind of players are we talking about here?
Well, first up, you've got your data ingestion specialists. Think of these as the sensory organs of the system, constantly gathering information from the environment.
So kind of like the sensors on a self-driving car,
Yeah.
right? Feeding the system information about traffic, pedestrians, even the weather.
Exactly. Or imagine the camera and microphone on your smartphone. They're like those data ingestion specialists, constantly collecting data about your surroundings and how you interact with your device.
Wow. I never even thought about it that way. Okay, so once this data is collected,
Yeah.
what happens to it? Does it just get thrown into a digital junk drawer somewhere?
Not at all. That's where our storage managers come in. They're the system's memory bank, ensuring all that data is organized, stored efficiently, and readily accessible when needed.
So in our self-driving car example, this would be like remembering the layout of streets or data about past accidents.
Precisely. But it's not just about remembering, it's about understanding the data too. And that's where the data analysts take center stage. They're the detectives of our team, sifting through mountains of data to identify patterns, trends, and anomalies.
So is this where we start to see true intelligence? Or is it just really sophisticated pattern recognition? What do you think?
That's a question that researchers are grappling with right now. Are these systems truly understanding the data, or are they just very good at finding correlations?
That's kind of mind-blowing to think about. But let's say these data analysts have done their job. They found the patterns, spotted the trends. What happens next? Who takes that information and actually does something with it?
That's where our decision makers come in. These components use the analyst's insights to choose a course of action, often in real time.
So in our self-driving car, this would be the system deciding when to brake, accelerate, or change lanes based on the information it's getting from the data analysts.
You got it. And what's fascinating here is that this entire process from data ingestion to decision-making often happens in a fraction of a second, especially in systems that need to react quickly to changing environments.
It's incredible how it all works together. But having these specialists is only part of the equation, right? What keeps them coordinated and adaptable? I have a feeling this is where things get really wild.
You're absolutely right. Having a team of specialists is impressive, but their true brilliance lies in how they learn, adapt, and solve problems together.
Okay, so walk me through this. What elevates system cognition from just a bunch of cool parts to a system that can actually think?
At its core, it's about learning from data. And I'm not just talking about collecting and storing information, but truly understanding and extracting insights from it.
So it's not enough to just have a massive digital library. The system has to actually read the books, so to speak.
Precisely. Imagine a self-driving car navigating a busy city for the first time. It might encounter situations it hasn't specifically trained on, like a double-parked delivery truck blocking a lane.
That's where the learning part comes in.
Exactly. The system, through its data analysts, would analyze this new scenario, identify potential solutions based on its existing knowledge base, and make a decision.
And hopefully avoid a fender bender in the process. But it's not always smooth sailing, right? What happens when things get a little more complicated?
That's where problem solving comes into play. Let's say our self-driving car is on a road trip and encounters an unexpected detour due to construction. The system needs to evaluate alternative routes, factor in real-time traffic conditions, and potentially even analyze data from other cars that have navigated similar detours in the past.
Wow, that's a lot of on-the-fly thinking for a machine. It's almost like well, thinking like a human would.
And that's the exciting and perhaps slightly unnerving aspect of system cognition. These systems are becoming increasingly adept at tackling complex problems that were once considered exclusive to the human domain.
It really makes you wonder what can't these systems do? But before we get too carried away, let's talk about the metacognitive manager. You've mentioned it a couple of times, and honestly, it still sounds like something straight out of a science fiction novel.
Yeah, it's a name that definitely sparks the imagination.
It does. So what exactly is a metacognitive manager? Is it like the CEO of the system cognition dream team?
That's a great way to think about it. The metacognitive manager is like the conductor of an orchestra, ensuring that all the different components, the data ingestion specialists, the storage managers, the data analysts, the decision makers, are not only performing their individual roles effectively, but also working together in perfect harmony.
So it's not just about making sure each specialist is doing their job. It's about making sure they're all on the same page, communicating effectively, and working towards a common goal.
Exactly. Remember our self-driving car encountering a sudden downpour?
Okay. Yeah.
The metacognitive manager might recognize that this new weather condition requires a shift in strategy.
So it might tell the data ingestion specialist to prioritize data from the rain sensors and then relay that information to the decision makers so the car can adjust its speed and braking distance accordingly.
Precisely. The metacognitive manager can dynamically allocate resources, fine-tune algorithms, and even integrate new information from external sources to optimize the system's performance in real time. It's all about being adaptable, flexible, and responsive to the ever-changing environment.
Okay, I'm starting to see how crucial this metacognitive manager is. It's like the glue that holds the whole system together, making sure it can handle the unexpected. But before we get too carried away with all this talk about thinking machines, let's bring it back to us humans. Where do we fit into this whole equation?
That's a critical point. It's easy to get caught up in the technology, but we can't forget the human element. We may not be writing every line of code, but we are the architects of these systems. We define their goals, set their boundaries, and ultimately bear the responsibility for their actions.
So even with all this talk about systems that can think, it still comes down to humans setting the rules of the game
Yeah,
and making sure those systems are used responsibly and ethically.
absolutely. Technology itself is neutral. It's how we choose to design, implement, and use it that will determine its impact on society.
That makes a lot of sense. It's both empowering and a bit daunting, right? We have this incredible power to create systems that can learn, adapt, and even solve problems in ways we never thought possible. But we also have a huge responsibility to make sure those systems are used for good.
It's a responsibility we can't take lightly. As system cognition continues to evolve, we need to be having open and honest conversations about its implications, the potential benefits as well as the risks.
Well said. It's a topic that's not going away anytime soon.
Or
In fact, it's only going to become more important as these thinking systems become more prevalent in our lives.
I completely agree. And that's what makes this whole field so fascinating. We're not just talking about bits and bytes. We're talking about the very nature of intelligence, how we define it, how we build it, and how we ultimately coexist with it.
It's enough to make your head spin, but in a good way, of course. So listeners, as we wrap up this deep dive into system cognition, we leave you with a question to ponder. What role do you see system cognition playing in your life, both now and in the future? It's a question worth thinking about because the future of thinking machines is in many ways up to us.